Frequency of a class is the sum of the frequencies from the first class through the current class. Find the cumulative frequency of each class below. Okay, so when we do this, we want to first start with the first class and then just copy the frequency that it has. So we're at a count of 11 so far. Then all we want to do is combine what we found in the previous class plus the new class. So do 11 plus 3. That's going to make 14. And so basically it's a measure of how many how many responses we got in the second class and the first class combined. Then when we go on to the next third class, we'll do 11 plus 3 plus 1, or 14 plus 1, which is 15. So this one includes the first class, the second class, and the third class. That's what makes it cumulative. You know you did it right if at the end you find that your cumulative frequency equals the number of responses that you have in the frequency distribution. That's a good way to check to see that it's done right. The relative frequency of a class is going to be the portion or percentage of data that falls in that particular class. And we'll do a division to find it. So relative frequency involves dividing the class frequency by the total sample size. So if I were doing relative frequencies for this distribution here, I'd want to first find out what is that sample size. So little n would be 11 plus 3 plus 1, which makes 15. And that's going to be part of the relative frequency formula. So here, the frequency is 11 in this first class. And we just want to divide that by the total number of responses to find out what portion of the responses come from that first class. As a decimal, this comes out to approximately 0.733. We can just round it to 2 decimal places if we wish. It doesn't say what to round to right now. But we could have that. And then we can also express it in percent form as well. To find the percent form, we simply multiply the decimal by 100%. So that will give us 73%. All right, let's try it for the others. Here we'll have 3 out of 15 for our second class. That's 0.20. As a percent, it would be 20%. And finally, 1 out of 15. .067, approximately 7%. All right, now one of the things that we can do to check that we've done it right is for any frequency distribution, we want these relative frequencies to add up to a special number. If they're in decimal form, then they should actually sum to approximately 1. And they may be slightly off because I round it. But basically, if I add those together, it's about 1. If we add them together in percent form, we want to find that the sum is 100%. That way we know all the data has been accounted for